Okay, in this video we're going to take a look at the next idea in time value calculations, and that is the idea of present value, finding the present value. And we're just going to rearrange the future value formula, and we're going to solve for the present value. So algebraically that implies that the present value is equal to the future value divided by 1 plus r to the n. So that process is called discounting. That whenever you hear the term discounting in this class, that's what we're doing. We're dividing the future value, some amount that's going to be received or paid in the future. We're going to divide that by 1 plus the interest rate raised to the number of periods, and we're going to end up with a smaller number. The present value is going to be smaller than the future value because we're dividing by a positive number. So that's the formula for present value. And let's just look at a few examples to hopefully get some sense and help explain it and the idea a little bit more. The first example here, we want to find the present value of $1,000 that is received 8 years from now if the interest rate is 6%. And by the way, this little thing in parentheses here, the discount rate, that's an equivalent term, a synonymous term to interest rate. Whenever you're discounting, you discount with the interest rate. You could also call that the discount rate, but it's the interest rate that you use to discount, so that's why that discount rate term is sometimes used. But they're both interest rates. They're both the R in these formulas that we're using. They're both the rate number or the rate input in Excel. So generally anytime you see that word discount rate, interest rate, that's what you're going to be using for the R or the inputs in Excel. In any event, let's start sticking the pieces and parts in here. We've got the formula PV equals FE divided by 1 plus r to the n, so the present value is going to be equal to the future value discounted by the interest rate raised to the number of periods. In this case, the future value is 1,000, so the FE is 1,000. We're going to divide that by 1 plus the interest rate, so that'd be 1.06 raised to the 8th power, and that is going to be equal to $627.41. So again, with a calculator, you would take 1.06, raise it to the 8th power. You would get 1.5938, etc., etc. And then you would take that number and divide 1,000 by it. And you would get the correct answer, $627.41. So that'd be with a calculator. In Excel, and we'll look at some Excel examples here in just a minute. Let's take a look first at another example here. What is the present value of $10,000 received 17 years from now if the interest rate is 8.5%? So again, we have all the important pieces. We have the future value, we have the interest rate, and we have the number of periods. Now we're just going to plug in and do the algebra where we solve for the PV. So $10,000 divided by 1.085 raised to the 17th power, and our result is $2,498.59. So again, we can do the calculations for present value with two different methods, two different instruments. One is the calculator. I don't really want to focus in on that, but we could take the 1.085, raise that to the 17th power, we would get 4.00226 and maybe some other decimals, depending on how many numbers your calculator shows. And then we're going to take $10,000 and divide that by that number, so divide it by 4.0026. The result is the present value of that $10,000, and the answer is $2,498 and some change. So we found the present value of $10,000 discounted back 17 years with a discount rate of 8.5%. The preferred method to do that calculation is to use Excel. We have two different choices, and I think the better of those two is using the Excel function. But you can use just the math formula where you solve for the present value by taking the future value, divide it by 1 plus the interest rate raised to the nth power. So for instance, we would take $10,000 and divide it by 1.085 raised to the 17th. So we would just type in this equals $10,000 divided by 1.085 caret 17. Alternatively, and preferably, you would use the Excel function PV. So that's the present value function. So you'd type in equals PV, and then you'd have some things in parentheses, these arguments again. And the arguments need to be entered in this order: the rate, the number of periods, the regular payment, and then the future value. So in this case, we would type in equals FV 0.085, comma 17, comma 0, comma 10,000, or negative 10,000. And we would get an answer, and the answer would be, again, $2,498.59. So why don't we go real quickly to Excel and take a look at those. Actually, we're going to look at a couple of different questions, a couple of different problems that are present value. So the first one here: find the present value of $1 million to be received 20 years from now if the discount rate is 9%. So we could stick in the calculation. So we take the future value divided by 1 plus the interest rate raised to the number of periods. So here it's $1 million divided by 1.09 carats 20, and we get the result here of $178,430. Or we could use the PV function. So in this case, we would type in equals PV and then put up parentheses. The first input is the periodic interest rate. And by the way, Excel, you have to put in the decimal form. So it's 9% would be entered in as 0.09. You would not put a 9 there. That would tell Excel something very different, and you'd get a really crazy answer. So the interest rate needs to be as in decimal form. So we put in 0.09, have a comma, the number of periods. So we have 20 of those, 20 years. The next comma is a 0 because there's no interim payments, there's no regular payments occurring along the way. And then finally, the future value, we're going to put it in as $1 million, negative $1 million. And we end up again with an answer of $178,430. I want to show you real quickly what happens if I take out the negative sign and enter that same formula in Excel and get the result. In this case, it just changes the sign of my output. So it's the exact same number, just with a negative sign in front of it. So let's look at the second question here. What would be the purchasing power in today's dollars of a $10,000 check received in 12 years if inflation was 3.3% per year? So this is a present value question. We're asking how much money would we have today, or what would be the value of that money today if inflation is 3.3% per year. Hopefully it's clear to you that this is a discounting operation. The $10,000 that we're going to get in 12 years isn't going to buy the same stuff that it would buy today, and we're figuring out how much stuff we could get, what value of stuff we could get in today's dollars. And so we're going to plug in the formula. We've got the future value of $10,000. We're going to divide that by 1 plus the interest rate, so 1.033. Raised to the number of periods, raised to that power, so we're going to raise it to the 12th power. Our answer is 6,773, or we could use the Excel function equals PV, where the first input is the rate, second is the number of periods, third one is any periodic payments or equal payments along the way, and the fourth is the future value. So we've got, in both cases, the answer is 6,773. So the $10,000 that you get 12 years from now would only buy $6,700 worth of stuff, at least in today's money, in today's prices. So that's the value, that's the present value of the $10,000 adjusted for inflation. So we're going to stop this video here, and we'll pick up with talking about lump sums and solving for number of periods and interest rates in the next video.